On June 24, 2026, a devastating and deadly magnitude 7.2 earthquake struck east-northeast of San Felipe in Venezuela. But then, only 38 seconds later, an even larger magnitude 7.5 earthquake struck to its east. As a result, the ground shook continuously for 92 seconds, involving an intensity and duration that many structures simply did not survive. These are the two fault segments each of these earthquakes ruptured, which stretch for 58 kilometers or 36 miles from the 7.2 quake and 197 kilometers or 122 miles from the 7.5 quake. The initial magnitude 7.2 earthquake caused a segment of the Bocono fault and then a segment of the San Sebastian fault to slip, while the 7.5 earthquake occurred purely on the San Sebastian fault. Both of these fault zones denote tectonic plate boundaries, although the San Sebastian fault moves due to motion of the Caribbean and South American plates. And now, I have overlaid how much parts of these fault lines moved from these events, with maximum ground motion being up to 2 meters or 6.6 feet. However, this chart only shows how much a fault slipped if its entire extent existed on the surface, as in reality, these faults dip at an angle of 74 degrees to the south, getting deeper in that direction. With this being said, fault motion for both earthquakes was pretty close to perfectly horizontal, with largely right lateral strike slip motion, where the southern segment moved westwards and the northern segment moved eastwards. The latter 7.5 earthquake with a now updated longer rupture extends all the way to and in fact east of the coastline north of Caracas, which helps explain why earthquake shaking was so damaging there. The current U.S. Geological Survey model that you can find online with contour lines showing how intense earthquake shaking was from these events in a particular area is somewhat inaccurate. I thus made a higher resolution map which better takes into account the ground seismic amplification of a particular area based on its geology. When seismic waves pass through sediments, they slow down, causing the seismic waves to increase in amplitude and causing far more severe earthquake damage. The opposite is also true, meaning that harder solid rock units such as solid granite cause seismic waves to speed up, have a lower amplitude, and thus produce less damage in a spot. Caracas, for example, is partially built on an alluvial plain, so some seismic amplification occurred within the city, leading to greater damage. Since MMI 6 is what, in my opinion, serves as a minimum to have the potential to cause some form of building damage, I have labeled the strongest MMI shaking each city of more than 100,000 people in Venezuela experienced, rounding to the nearest interval of 0.5. I have also noted multiple towns, cities, and settlements which experienced MMI 8.5 or MMI 9.0 shaking, the absolute strongest these twin earthquakes produced. Puerto Cabello was especially hard hit due to being the largest major population center to receive MMI 8.5 intensity shaking. The San Sebastian fault has previously produced 2 deadly major earthquakes in historical time, with a deadly 1812 earthquake sequence causing more than 10,000 fatalities and a 1900 earthquake causing 130 fatalities. However, just like the June 24, 2026 earthquake, there's still a topic of much debate regarding the 1812 earthquake. What's up for debate is whether 2 separate closely spaced earthquakes in time struck with a distinct pause in between them, or whether a single larger earthquake happened that just involved at least 2 distinct segments slipping with a slight delay between the two. If, for example, the 2 June 24, 2026 major earthquakes were in actuality a single earthquake, then its magnitude would have actually been around a 7.6. Us scientists likely won't know for sure which of these possibilities accurately describes what happened, and we likely won't find out for multiple months until someone performs and publishes a scientific study discussing such. In my opinion, I also think that a decent chunk of structures which did collapse specifically collapsed due to liquefaction, although I would not suggest that a majority collapsed from liquefaction. I am suggesting this because many photos have come out showing structures which collapsed only on one side. However, I want to note that such a collapse can also occur due to earthquake shaking in of itself when the initial surface waves arrive. Please stay safe, everyone.